Here's the text with improved punctuation. Once more, have you ever considered what our sun looked like when it was an incredibly young star? The James Webb Space Telescope has made an amazing disclosure about our star, as we can now see it in a totally unique light. The JWST's most recent findings offer hypnotizing insights into the youthful times of stars and the huge cycles that could have occurred in the early stages of our sun. Have we now unlocked another of the universe's great mysteries because of the new James Webb Telescope? What secrets still await us out there in the universe? The James Webb Space Telescope is a perfect representation of the advancements made by cutting-edge technologies. Since the telescope's launch, the examination of the universe has progressed at a rapid pace. With its latest mission, the JWST has demonstrated its remarkable ability to delve deeply into the universe's secrets. Indeed, the telescope showcased its absolute technical superiority when it imaged the object HH21 with extraordinary magnificence. HH21, also known as a Herbig-Haro object, is a very young star, yet advanced enough that it is blowing strong jets into the universe and beginning to shape its surroundings. Since its study by the JWST, the object has provided a wealth of critical information about the energetic period of stars and, consequently, the early stages of our own Sunday. These observations equip us with vital data about the processes occurring during the initial stages of stellar evolution. Herbig-Haro objects are among the most fascinating astrophysical phenomena in regions of youthful stellar development. They consist of narrow jets of gas shot out from newly formed stars and streaming into the surrounding interstellar space at high velocities. These jets collide with surrounding gas and dust, resulting in dramatic emissions. Herbig-Haro objects were discovered in the 1950s by astronomers George Herbig and Guillermo Haro, who were independently studying star-forming regions and initially observed the massive outflows. Before the JWST era, the energy-rich jets from the center of a young star were astonishing. Who would have thought things would be so violent in the stellar nursery? Young stars are far from cuddly. They are indeed beautiful but also incredibly powerful. We can hardly imagine the forces at play here with our minds alone. The forces leading to the formation of a star are immense, and even in the early billion years, things heat up around a young star. It takes countless years for a star to eventually shine as smoothly and steadily as our sun. The object of the latest observations, the Herbig-Haro object HH21, is located in a star-forming region in the constellation Perseus, about 1,000 light-years from Earth. HH21 is especially intriguing as it is one of the youngest and closest examples of these objects, making it an ideal field of study to explore the physics of star formation in detail. The discovery also provides us with cosmic views of the dynamic processes that likely occurred in the early stages of our sun's life. The JWST has imaged the Herbig-Haro object HH21 with exceptional precision, offering even more fascinating insights into what was previously difficult to see. For the first time, it might even be possible to observe a double star formation at the center of HH21. The images reveal two bright, high-energy jets emanating from a central point. These jets are enriched with particles such as carbon monoxide and silicon monoxide, and are evidence of high-energy processes within the star and its fast-moving environment. The discovery of atomic hydrogen within the jets was a significant surprise and now provides a completely new picture of the substance structure and thermodynamic conditions in the early stages of star development. The surrounding accretion disk of the young star, along with other objects such as planets and moons, could also form. However, the intense outflows from the jets might make the formation of stable bodies more challenging. Nevertheless, the JWST studies further showed that the jets of HH21 are slower than those of many other Herbig-Haro objects. This slower speed might indicate that the star is at an early stage of development or that the processes in this young system are generally less turbulent than in other stellar nurseries. The ability to observe such key cosmic processes up close and with high precision represents a significant advancement in cosmology and will lead to ever more intriguing discoveries in the future. Observing the birth of new stars also provides insights into how ionized gases and plasma interact. The energetic jets that influence the cold surrounding interstellar medium create brilliant shock fronts that act as visual boundaries of the young star systems. These early outflows of a star are akin to the protective shell of our sun's heliosphere. On a scientific mission with the JWST, research teams are excited about the additional possibilities. The JWST is equipped with a range of innovative scientific instruments, including the Near-Infrared Camera (NIR-CAM), the Near-Infrared Spectrograph (NIR-SPEC), the Mid-Infrared Instrument (MIRI), and the Fine Guidance Sensor (FGS). These instruments can detect even the faintest light from very young and distant objects that would otherwise be invisible to our eyes. By using infrared technologies, astronomers can now see through dust clouds to reveal previously hidden corners of the universe and gain direct insights into young stars and their formation regions, often obscured in thick dust shells. Thanks to the high sensitivity of the JWST, astronomers and space enthusiasts alike can enjoy a level of detail that has never before been achieved in the history of astronomy. The JWST can not only image these faint light signals but also analyze them. Never before have scientists been able to see such detail of the massive jets in precise studies, providing information on the development and temperatures of the gases, as well as details of all the chemical elements and molecules involved. Herbig-Haro objects, typical of dynamic star-forming regions like the Orion Nebula or the Perseus constellation, are significant for studying chemical processes in space. These regions are rich in gas and dust, providing ideal conditions for star formation. Stars are formed from the accumulation of these collections of matter, influenced by immense forces. The jets ejected by young stars, which travel through space at speeds of several hundred kilometers per second, are only part of the dynamic processes occurring during star development. When these jets interact with the surrounding medium, they heat it up and create the characteristic bright arcs and knots visible through our telescopes. Within this vivid display, immense physical forces are at work, alongside light emissions of elements, as well as electrical and magnetic forces. Captivating observations reveal how the jets interact with the surrounding material, helping to shape the cloud from which the star is formed. Each emission line and each color provides the JWST and, consequently, the researchers with valuable clues about what is happening here. Observing these processes live and in their early stages is akin to getting a direct look into the formation of a star. By understanding how matter is incorporated into the cosmic cycle and how the final mass of a star is determined, including the components and gases involved, we can make significant conclusions about the forces at work. This, in turn, helps us understand the overall matter formation processes in the universe. Although we might imagine that star formation is one of the great energy processes known to humanity, it is hard to grasp that such a young star can produce winds extending several hundred light-years and blow them into space. The jets of Herbig-Haro objects could be direct remnants of the immense angular momentum that causes dust disks to start rotating and coalescing in the center. Nevertheless, it is possible that the young star uses the jets to expel the forces it no longer needs while driving formative processes in the gas and dust cloud. So far, we have only observed jets in young and actively forming stars. However, we are also aware of very old galaxies in the universe that also produce powerful jets in their dynamic centers. Some of these massive jets extend far beyond their galaxies. These winds likely also disperse huge amounts of material, which ultimately impacts the mass of the star and the environmental conditions of the star-forming region. The material and energy expelled then drive further star births or other processes in the universe. We should briefly consider the role of magnetic fields around a young star. Magnetic fields are crucial for controlling the gradual accretion process in which the star draws in gas and dust from the surrounding disk and also affect the direction of the jets. Magnetic fields are not only significant in the immediate vicinity of young stars but are present throughout the universe. These invisible forces guide the paths of charged particles and influence the shape and development of entire star systems. In our own solar system, the magnetic forces mediated by the Sun's magnetic field are essential for maintaining the heliosphere, the bubble that protects the entire solar system from harmful cosmic rays from interstellar space. The Sun itself produces a complex and variable magnetic field that determines the arrangement of our planetary system, impacts planetary atmospheres, and regulates space weather patterns. Sunspots, solar flares, and coronal mass ejections are signs of the Sun's magnetic activity. As you may know, such events sometimes significantly affect satellite operations and communication systems on Earth and produce auroras. The study of magnetic fields and young stellar systems like HH21 is an exciting field of research and is still in its early stages. If we understand the development of stars in distant regions, we can also gain insights into the history of our Sun. Our star is 4.5 billion years old and has undergone many changes since its birth in a dust and gas storm. The origins of the solar system are determined by how planets were formed, from the solid Jupiter to the rocky planets, including Earth, to the gas giants and small bodies like Mercury and Pluto. They were all somehow present in the early stages of the system, or their unique conditions helped shape the formation of the planet and thus the broader climate. The study of the universe through advanced telescopes like the James Webb Space Telescope opens windows into the deepest corners of space, revealing phenomena that were previously invisible or poorly understood. With its cutting-edge technology and exceptional capabilities, the JWST represents a significant leap in astronomical research, offering unprecedented insights into the evolution and formation of stars, galaxies, and cosmic structures. The universe is rich with mysteries and wonders waiting to be discovered, and the JWST continues to push the boundaries of our understanding, providing new perspectives and revelations about the cosmos.